in this real-time world, you can have the ability to actually stop wasting by bringing in transportation through EVs to the grid. You're taking off emissions there. So the more you can bring to this overall grid infrastructure, the better you can manage the overall energy conversation. And it's all to do with data and the backend infrastructure, as in the computing backend infrastructure.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington, and today I'm joined by Laurent Boinot. Laurent is Power and Utilities Lead for Americas at Microsoft. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Laurent, welcome to the podcast.
Thank you, Sam. Thanks for having me.
I'm looking forward to digging into our conversation. We'll be talking all about AI and energy. Before we dig into the topic, I'd love to have you share a little bit about who you are and what you do.
So I am initially from France, but I live in Toronto, Canada. I'm Canadian as well. And my background is basically consulting for the energy sector. I have an experience as an entrepreneur as well. I had my own online learning company. And then when I sold the business, moved to Canada with my family. And I've been at Microsoft now for 3 years. Focusing on power and utility, covering the entire continent with an S.
Energy and AI is a potentially very broad topic. How can we maybe start to frame out the role of energy and some of the levers that AI can begin to manipulate?
Yeah, so I think it's important first to talk about what energy is and what it isn't. Because if you ask kind of the average person, or me before I took this role, basically, you think about energy like the price on your bill, basically, or filling the car, or if you're an economist, you think about energy as a sector of the economy. But energy is really our ability to change the world. And I don't mean that in a big philosophical way. I mean that's actually the definition of the word energy. If you do anything, you either release or use energy. So if you change the temperature in a room, that's energy. If you lift a piece of paper or anything, that's energy. The heavier, the more energy. If you drop it, it releases energy. So in a very real sense, the energy sector is all about making things happen, and in an even more real sense with the advance of the Industrial Revolution, because the way basically the energy sector is feeding the machine, if that makes sense. And a lot of our lives, from driving, but also from food production, from obviously anything we wear, anything we manufacture, is dependent on machines, and the machine eat energy, and we eat the production of processes that involve machine as well. So it's very, very core. That word energy is very, very core to anything we do. And so, having kind of laid that landscape, you can then talk about the fact that obviously reliable access to energy has everything to do with economic growth and job creation, and then you can talk about the technological innovation that enable some access to energy, because things that relied on more energy before can be done now with much less energy, but also energy itself allows for reaching out to more energy. And you can talk about the kind of geopolitical implication of reaching for energy. You can talk about the resilience, the disaster preparedness of energy production. But in my role specifically in power and utility, I'm at the crux of the environmental impact conversation, because we are going from a world where, when I say energy now, it's mainly electricity. So electricity consumption, energy consumption, was stable, basically in line with population growth, to now with data centers and electric cars and the electrification of a lot of processes, including steel mills, by the way. We're now in a situation where the grid, so the big meta machine or meta system that allows us to distribute this electricity around, that big machine may need to be upgraded with actual, shovels on the ground, new transmission lines, new generation, more smarter distribution, but also upgraded and digitized, made smarter to enable the future we want, rather the future that we will get if we don't do anything.
One thing that's key there, and I guess it's obvious to anyone who thinks about it, and we've been talking about it for a little bit, and that is that there are two sides to the impact of AI on power in particular. One is the load that AI and data centers are creating, and the other is opportunities for optimization and more effective distribution. How do you characterize the impact of data centers and AI? Have you do you follow any of those stats about the how the growth of AI is impacting power more concretely?
Yeah. So Microsoft is opening Microsoft is opening one data center every 3 days. So that in a very and those are not a server in a cupboard.
Literally new data centers every 3 days.
Yeah.
And
yes.
Is that rate projected to continue or accelerate?
Right now, yes, because the big bets are security and AI at the moment. But there is a fact to answer your question. There's a fascinating tension between the increase in data centers, therefore increase in consumption, AI also with a interesting retroactive loop, allowing a lot of efficiency gains in the system, but also AI going from being statistical models to very, very power hungry Gen AI models. And then those Gen AI models going from LLMs to SLMs. So by that, I mean that the huge power requirements of training a large language models may not necessarily be replicated when you train a much smaller model that can do the same thing as the large language model did 6 months before. And also there is an efficiency gains in the chips every generation. So there's a lot of different graphs with different exponentials in different directions.
I was just going to jump in and say, even on its face, like the data center every 3 days is surprising from the perspective of it surprises me. And I think some of the context that I was bringing to the conversation is like thinking about, the rise of cloud computing and how that has meant a consolidation. I wonder if, if we think about enterprises closing data centers and companies like Microsoft opening data centers, like what the net new data centers is that positive or negative?
So that's a great question, and it's definitely positive. The net is positive. You'd have to close a lot of data centers to net out the impact of the.
And I also would have thought that the data centers were getting larger, more so than opening up new ones.
Yeah, but there's also value in being. There's several things here. There's value in being close to your customers. There's value in having obviously redundancies, so you don't want all the data centers in the same place. And there's value in being close to new generation, and also some local regulations basically force hyperscalers to have local data centers as well.
It surprises me a little bit as close as I've been to this from the cloud perspective and generally from the AI perspective. That's still a surprising number in terms of new data centers opening.
Yeah, but again, going back to trying to figure out where this is going, like putting my old McKinsey on and trying to predict the future. You can keep going with the exponential and try to figure out how much consumption the data centers will have eventually. But an interesting data point for me is looking at you today using Bing or ChatGPT on your device. And when you do that, you actually obviously don't use it on device. Your device is just sending a request, and in a big data centers, actually on Azure, in both cases, the request is processed, and then the answer is sent back to your app, right, on the device. And that was the state of the art not so long ago, not 6 months ago or so. But with small language models that Microsoft is working on, and others, like 5.3, for instance, of Microsoft, you can have the same output on device. And so that bit consumption that I just described is gone. So maybe your device will get a bit hotter. Maybe you need to charge slightly earlier tonight. But still, we're talking about a 10 times reduction in consumption or more. So the conversation is much more complex than just keep plotting a line up. It's more, the answer lies more into and that goes back to your question about closing data centers at clients as well, closing on-prem data centers. So the question of what the future will look like is a lot about what you do with this intelligence, because you have this like deep artificial intelligence now, and is it just fun and games? It's just something you do on the side. It's just a request a day just to confirm it works, or do you deeply strategically reinvent your business with these new capabilities? And if you do, then you rely very, very heavily on processes that today consume a lot of compute, therefore a lot of power. Microsoft has a mandate to be carbon negative in 2030. And that means removing all carbon from data centers by 2025, which is next year, at the end of next year. And there, basically, that means that for Microsoft to keep operating, you need a reliable, clean energy. And that's interesting for two reasons, well, many reasons, but the two main reasons for the purpose of that conversation is how does that work? Like, what needs to happen on the grid? How much solar power you need? How many roofs do you need to cover? How many new clean power station you need to have in place to make that happen? But also, from an AI standpoint, what needs to happen on the grid to prove that the electron you just got is a clean electron? Because there's a big difference between being net clean, which means that you are consuming, let's say, 100 megawatts of energy, and you've also bought 100 megawatt of clean energy, and actually knowing that every single megawatt that you have bought was actually produced cleanly. And that's a very different conversation. And that's something we're working with at Microsoft with partners like that Constellation, for instance. We have a tool called 24/7 matching, where we can confirm exactly that.
That sounds a lot like some of the work that's happening in other supply chains to ensure, some degree of fairness. I'm thinking like fair trade for food and similar types of governance regimes.
Yes. So I'm not an expert in those areas, but one of the specificities and one of the things that makes power and utility absolutely fascinating is that when you want to eat a tomato in my world, you have to grow it the moment you want to eat it. There's very, very little ability to actually conserve the tomato somewhere, like to put it in the fridge or in the freezer or to stock it anywhere. So the electrons that allow our conversation right now, or the electrons that allow people watching or listening, were created like for us right now. In my case, somewhere in a nuclear power plant near Toronto, right now, not 6 months ago. So the whole conversation around how do you add renewables to the grid, or how do you prove that your electricity is clean, is really a real-time conversation. You don't have to, you cannot go back and actually trace. You have to do it at the moment.
You made a comment, if I'm remembering correctly, in one of our previous conversations that suggested that from the perspective of the power grid, having too much power is just as bad as having not enough power?
Yeah. Sometimes you read in the press that uh, the price for electricity goes negative, and there is a lot written about, maybe there's something wrong with the market. But no, it's quite simple. This morning, you had a shower, and I'm sure you paid for the water, right? You were happy. You knew that by getting under the shower, you were expecting water to fall in your head, and you were happy to pay for that water to fall in your head. When you get out of a cab in a windy New York November evening, you are happy to pay for an umbrella to stop the water from falling on your head. It's the same molecule, it's the same head, different situation, right? So it's exactly the same for electricity. If you don't have enough of it, that's a brownout or a blackout. You need to cut distribution lines, and for whatever reason, that's a big problem. Um, when you have too much of it, it's also a big problem uh, because it actually results in the same situation where you end up with fuse going off, and you basically cut lines as well, and the end consumer is affected all the same. So this necessary, and again, it's not a 6 month by 6 months balance you have to find. It's a real time balance in the generation and consumption of energy. But that also means that, and it's worth digging into this, when you think about right sizing the grid, or making sure that in a specific geography you can adapt to a growing population or new factory or new usage. We can talk about new usage for electric cars, for instance, or when you bring in new power through renewables. Again, think about the water on your head. Is it water that's falling where you want the water to fall, or is it water that's falling where you don't want water to fall? So if you have a new usage in the evening with electric cars charging in the evening, can you compensate that by bringing uh, new generation, new solar generation during the day? No, there's storage in the middle. Otherwise, you have an imbalance. You add more to the grid when nobody's using it, or not enough people, and then you want to take electricity from the grid when you haven't added any generation at night. So that's why I said that in the whole sustainability conversation, obviously renewables are absolutely part of the conversations, and you have to move away from coal and a lot of things like that. But you always have to keep in mind two things when you think about adding generation to the grid. Um, One is, um, am I adding something that I can turn off or on whenever I want? That's key. Um, and two, what is the charge factor? What I'm adding on? So is what I'm adding on does it have the ability to work for a whole month if I want to, or will it be on and off during this month? If you think about what's happening behind the meter, the reason why the whole industry is looking at smart meters and advanced metering infrastructure is because understanding what happens behind the meters not only allows you to more precisely predict what you need on the generation, distribution, transmission end, but you can also, by adjusting consumption, uh, answering some of the previous conversation we were having. Like, not consuming is the same as bringing more power in. So it's called peak shaving. So you have to size the grid for the peaks. If Otherwise you will have a brownout basically.
So what are some of the ways that AI is playing a role in helping energy companies, power utilities manage the complexity of delivering power, forecasting demand, all these things?
Yeah. So forecasting demand is a great example. Uh, so the energy industry, the power and utility industry, has a crazy amount of data, not used at all to its full potential at the moment, but there's a crazy amount of data. And if you think about what used to happen in the past, still happens in most places, with the old-fashioned meters, you basically literally you read the meter by sending an employee who will open a little box and confirm how much power was used in the past year, for instance. So we have no understanding, no visibility as to when and why that power was used. And the whole value add of the smart meters. Sometimes we think about smart meters enabling the distributed energy resources, like allowing solar power, allowing you to rely on your own little windmill. But it's more basic than that. It's just making sure that the provider of energy really understands where the need is. And we we had a project in Canada where we were able to help our customer, a power and utility company, use uh, uh, data from the meters to identify areas of the city that needed new substations and new transformers, because we were able to detect the presence of electric cars because of the data usage. So this is an example of how this feedback cycle, this loop that you didn't have before with the kind of quote unquote dumb infrastructure. Um, you would not able to see that, and we just get a brownout potentially. But then also AI is a big part of allowing what's called virtual power plant or the prosumer, which is when individuals have solar roofs or their own again small windmill. Um, uh, they then can supply the grid, and or in some cases be almost off the grid and only use the grid for resilience, because they with a small battery they're able to just never really use more than what they've been able to store the day before. And all those all this is managed automatically through AI systems. And I'll keep going, because something that's fascinating to me is some of the conversation around electric cars. So there are different levels. Obviously, there are the petrol heads that just will never get over the fact that an electric car doesn't smell out of petrol. So okay, let's move on from that. That's a different conversation. Then there's a conversation around are they really more sustainable than the old-fashioned internal combustion engine cars? Because yes, there's a lot of mining required for the battery. In my opinion, that conversation is dealt with already. If you never use your car, if you literally buy a car just to look at it, which some people do on the high end, but not the average person, it is possible that indeed just having a normal engine is less taxing on the environment. But if you actually drive your car, you need to burn oil, and in that case, the electric car would be far superior over even a short life, even over a short lifespan. So that's the second conversation. The third conversation is trying to understand the impact of EVs on the grid, and this is absolutely fascinating because you see a lot of kind of badly plotted graph or kind of rough order of magnitude estimates, but that really, in my opinion, really miss the crux of the conversation, which should be, how much energy do people spend driving a day? And can the grid cope with that? That's the only thing that matters. If you look at the physics, the question is, how much energy do you need in your car? And can the grid provide that for everybody or like a neighborhood? The question is not, can everybody supercharge their car at the very, very same time on the same day? If that's the question, then yes, the grid cannot cope with with people driving EVs. But that's not what the question should be.
And are you referring to incentive schemes and others like what you mentioned earlier in terms of distributing load and getting people to charge at different times?
Yes, that's part of it.
I mean, if you don't have control over everyone plugging their car in at the same time when they get home from work at 6 o'clock, like how is that not the question?
Exactly, but it can be a lot more basic than this. It can be just making sure people understand that they don't need their car to be full in the morning, for instance. I don't have the stats in front of me, but I think the average American drives 30 miles a day. Um, an electric car is typically, close to 300 miles of range. So if you come back home in the evening, you might not even need to charge for a week in some cases. So the idea that really the grid needs to be dimensioned for that charging every night, first of all, that's not the right question. But also, the speed of the charging it's very, very different. If you want the swimming pool to be filled in 6 months, then we'll just put the garden hose and wait, right? Yes, there'll be some evaporation from the sun, but it will rain as well. So all in all, just wait. If you need to be filled in 10 minutes, then you need a big truck or like a big plane to come immediately and dump a much of water in it. It's a completely different architecture. It's a different mindset, and the physical world needs to look different for a different reality. So like when I don't actually own a car, but I typically rent electric cars when I travel, and I now understand that even with 110 in the US and in Canada, that's typically enough for the driving I do during the day.
I mean, we're talking broadly about the ways that AI can be used to aid power companies and utilities. They've got access to, tons of data from, these smart grids that they're putting in and, various sensors that are across the grid. Like what specifically are companies doing to try to take advantage of that data and use AI?
So one example we've seen on the transmission side, we haven't really talked about transmission so far. So transmission, it's you have generation, which is where the electricity is generated. Generation. This distribution is how it gets to the customer, and the transmission is in between. So it's the big power lines, and there's a physical limit to how much electricity can go through a cable. It's the size of the cable, the temperature. It's also the curvature of the cable, the sag. And so we've done work with customers in estimating the ideal sag of transmission line. There's a big difference between putting a bit more tension on the cable so it sags less and therefore can conduct more, than digging a big hole and putting a pylon next to it in a forest all along, right? And we've also done work around inspection for fire hazards and for vegetation management. It's a big issue in Canada and in the US as well, where you have pylons crossing a forest and the forest grows. And at one point, the forest, might be too close to the actual transmission lines, which can create, short circuits and forest fires. You don't want that, obviously. And so there's a lot of work done with inspections, automated inspections, automated warning of inspections, and there's even work done around using a Gen AI layer for the staff at the power utility company to communicate to robots. So instead of having to learn the language of the robots or drones that will then go to inspect power lines, you can ask them in natural language what they need to the robots. And then on the purely software end, there's a whole sustainability suite which is similar to an ERP. So ERP typically is in the finance world. You have an accounting software that takes data, helps you make sense of the data, create reports, and Microsoft, others as well, obviously. But Microsoft has a tool that allows a company to really understand at a deep level, as deep as you need to go, basically on the ground, its emissions and what it can do to manage the emissions, and then all the reporting requirements as well. So both from let's really understand how to manage our emissions, and also let's create the reports that satisfy any regulations we might be subjected to. The power industry is very regulated, and we've seen customers starting to use Gen AI capabilities to create some of the key documents they need to operate. So I can give you two examples. So one very concrete example is rate cases. So power and utility company typically, for the regulated ones, typically earn a rate of return on their assets. And when they need to increase uh, when they need more money, basically, they need to put together a rate case where they explain what they're going to do with the money. Uh, it's a bit like a teenager and you need more pocket money. And so to put together the cases, um, they now use Gen AI for the format to kind of automatically reuse some of the wording from prior years, to automatically integrate with other systems and pull in data and give them a really strong draft. And that can be used on the other end as well by the regulator to make sense of a very complex document that fits the format of what is asked for, but can be very complex. And an even more extreme example of this, which at this stage is an idea, but we'll be looking into the the nuclear sector, because the nuclear sector is even more regulated, rightly so. Um, and we often think, as normal human beings, as the need for paperwork at the beginning of a project. Like you build a house, there's paperwork for building the house, and then you live in the house, and maybe there's paperwork for destroying a house at some point. I don't know, probably, but there's not too much paperwork on an ongoing basis. A nuclear power plant has very much the need for ongoing paperwork. Anytime you bring in new fuel, or you get rid of spent, you produce spent fuel, and then the spent fuel has to go somewhere to be treated or stored. That needs paperwork as well, and so that's an area where you can imagine Gen AI being used as well here.
How prepared are utility companies for, applying both of these types of models? We don't think of utility companies as like being at the cutting edge of technology.
Yes, there is a slower rate of innovation in that sector than maybe you would see in other sector, but it's such a consequential sector that there's a good reason for it. Um, in any case, to answer your question, um, it's yeah, I'm a former consultant, so I have this 4x4 matrix in my head. I think it's not really the type of AI uh, that makes it difficult or easier to adapt to. It's how that how those models are accessed. And so the 4x4 I have in my head is really, as you said, you've got the kind of old-fashioned quote unquote AI from like a decade ago or so, the ML and basically the very advanced statistics, right? And then you have Gen AI, where you can actually produce content. And so that's two different types of models. Yes. But the way you access the model, so are you actually creating the model yourself, or are you deploying the models in your Azure subscription? And are you having to handle all this? Or are you, like you and I, when we use spam detection in our mailbox, are we struggling to use AI? Would our parents struggle to use AI in that context? They don't even know there's AI in that context, right? So the answer is no. It's easy. It's Gen AI is almost the same. So deploying Gen AI in your subscription, I have customers who did that. In fact, Ontario Power Generation, the power and utility company based in Toronto, has a year ago deployed their own ChatGPT version. Like um, they use an OpenAI model on Azure to deploy ChatGPT, a model that a year ago was able to speak French and English, and then they added capabilities in some native languages as well, native to Canada. Um, and that tool is used to discover documents internally, but also interact with customers in some cases. Uh, so that's one thing that requires, especially a year ago, that requires a lot of innovative foresight. But I would say for the Gen AI piece, it is much easier when Gen AI is integrated into your search engine or into Bing or into what you do on with Microsoft 365. You open a Word doc and it suggests a few lines for you, or you go into Teams and you ask for the recap of meeting. That requires less innovative muscle, but not none. because to get the most value out
You
of
have to
it,
understand the models. You have to understand how to prompt them, how to use them, that kind of thing.
yes, that's true. The prompt engineering side is definitely something you have to have in mind, but also to get the most value out of it, you need to understand what the new capability of the system changes for the reality of your business processes. And that's where we work hand in hand. I mean, I work directly hand in hand with our global system integrators, the Accentures of this world, but also the strategic consulting companies of this world, to understand like how how everything needs to change basically. And then once you've figured that out, like what is the rollout process and how you make the culture evolve at the customer, what change management looks like, how the culture will evolve and how the day-to-day job will evolve. And I don't think I don't think it's quotable quite yet, but one of my customers in North America, after testing a off-the-shelf Gen AI. So I'm talking about the SaaS model Gen AI. You don't need to deploy it on your own server. You don't need to create it yourself. You just take something that exists. But after a little pilot, figured out that each of their employee were saving an average of 8 hours a month of work. So that's a full day every 20 days of work, which is significant. Oh.
What I'm hearing you say in response to kind of this innovation question is that, there's a couple of aspects. One is that generative AI models in their usage present a bit less complexity than the more traditional models, perhaps. And also that these models, in either case, offered as a service, eliminates a lot of complexity for the user, and they can supplement their skills, in tackling the remaining complexity by partnering with the systems integrator and others. So in other words, the, fairly or unfairly whereas these utilities are not necessarily considered to be kind of cutting edge innovators, there's enough supporting infrastructure to enable them to, apply and use these technologies and get significant advantage out of them.
Yeah, that's right. And to stay on the topic of innovation in the power and utility industry, and to look into what AI can do, but also sustainability as a topic. So at the intersection of those three conversations, we have a partnership with a non-for-profit called TerraPraxis. And what TerraPraxis does is identify co-power sites that can be repowered with small modular reactors. And the idea there is that those sites are not in the middle of national parks by definition. They are already connected to the grid, obviously. Otherwise, there would not be coal generators there. And so they are the perfect fit for those new nuclear reactors. Rather than trying to figure out where we can build them, we can just take out coal and replace by nuclear. Because the fascinating thing is, again, in this industry, everything seems very remote, very complex, and there is a lot of complexity. But when you look at what happens at a nuclear site, and what happens at a coal site, and what happens at a gas peaker plant, you are boiling water in the three cases. You're literally using fuel to boil water, and the steam will go through a turbine, and the turbine would generate electricity. And so a lot of the hardware is already there for to turn a coal site into an SMR site.
In talking through the innovation side of things for the power and energy companies, you mentioned one of the primary challenges that they have to deal with, and that is security and some of the challenges there. Are there other challenges that you see coming to the fore in this industry that need to be overcome in order for them to fully adopt AI solutions?
Yeah, so the main challenges for the sector is really, yes, you said security, sustainability, reliability, resilience as well, affordability. So you need to have power all the time when you need it at a price you can afford. Otherwise, nothing makes sense. Secure, obviously, we've talked about all the hacking risks, and you can. I mean, there's enough movies you can imagine what can happen. And resilience is really important as well. So not only do you need the grid to be reliable and work when you want it, but you also need to get it back up quickly when there's anything wrong happens. So I don't know, an earthquake or something unpredictable. So that's quite key. And that you can actually find kind of both this dimension as well on the AI front as well. So for AI, the main conversations as I see are around ensuring fairness, transparency, privacy as well. There's a lot done to clean off PII, and so you can do all the compute you need to do without the private information. We're doing some work. I should have mentioned this, but obviously a lot of work we do as a tech company with our customers in power and utility are non-power utility specific. So we could do work around their security suite and building a Gen AI layer that allows basically the screen to stop flashing red all the time. And rather than flash red, just make sense of the fact that, that door is open, but that door is open as well, but those doors are in different buildings. Whereas that door is open, but that door is open, but those two doors lead into each other. So actually the building is open. And you can have an AI layer to make sense of this from a security standpoint. But also you can add a Gen AI layer, which would explain to you the risk that is flagged up. So this is flashing red because this has flashed red, and this is amber, and the two together are really worrying. And also this is a suggestion of the next step you could take to solve the problem. And oh, by the way, you need to report this to the board, and here's a draft document for you to complete to present to your board, explain what was the actual issue, what you did to solve it. So that's all happening in the background across industries, but it's very key for power utility. The fairness and transparency are also important. So I mentioned that a lot of work is done to shave those peaks, right? To make sure that rather than bringing online a whole new power plant that you need to invest in that will have an impact on the environment, you can just ensure that the demand is slightly lower during those peak times, and that raises a whole bunch of fairness issues. Are you just randomly turning off people's electricity? Are you turning off certain types of neighborhood? Are you turning off only people who've kind of signed up to the approach, like Hilo does at Hydro Quebec? There's a lot of kind of fairness, unfairness conversation you can have here, and also even if you turn off, well, if you throttle back the electricity for anybody, is it fair on the people who cannot afford to have backup power at their home? Because if you have a battery at your home, you may not care at all, like if you can afford a battery. But then that leads into a further conversation about enabling this for everybody. So I say everybody. Most Americans have a car, and like a lot of those who don't have a car have chosen not to have a car. I'm a good example of somebody who could have a car and doesn't. Those vehicles have a battery and could become the backup battery to your house. This is called vehicle to grid. There's a lot of software interface there and some AI to ensure this works well. But anything I've talked about regarding how a battery can enable a customer to kind of smooth its peaks at a kind of household level has a big impact on the overall grid, and that's enabled by the electric car. So not only is the whole conversation around peaks because of electric car, in my opinion, a bit of a misnomer, but also the vehicle to grid potential of electric cars can allow the average power the kind of minute to minute consumption on the grid to be much smoother, like the daily curve to be much smoother, and that would change everything.
It's an interesting take. You're essentially kind of saying that with sufficient intelligence in the grid, that the electric car can be essentially batteries on wheels that kind of provide this ancillary service of transportation, but otherwise help support the grid in smoothing out these peaks and being more resilient.
Yeah. And it's all to do with data and the backend infrastructure, as in the computing backend infrastructure. Because you read all the time that 50% or 40% of the food in the rich world is wasted. But if I open my fridge tonight and I realize that I've let the pasta I cooked last night or the week before is now is not good enough to eat, what can I do? I didn't know about it, and anyway. If it's almost too bad to eat, it's too late anyway. But with electrons, it's much easier to move the pasta around, right? And so because we're in this kind of real time world, but at the same time that moves at the speed of light, close to the speed of light, you can have the ability to actually stop wasting and really being way more efficient in the way you manage the overall system. And when I say system, I've talked a lot about power and utility, but by bringing in, transportation through EVs to the grid, you're taking off emissions there. So the more you can bring to this overall grid infrastructure, the better you can manage the overall energy conversation. Going back to the start of the conversation, and those. By the way, those grids are interconnected. The main regions in the US and Canada send power to each other, um, and um, and this helps again, like shave the peaks and transfer the load to achieve a like a perfect equilibrium, which you need overall in the grid. So it's a absolutely fascinating industry at the very very core of everything.
And do you have, beyond greater adoption of AI, do you have a take on kind of where it's all heading for power and utility?
So my hunch, which is widely shared, is that the need for power will greatly increase because transportation will be brought in, uh, will be technically part of the grid because of increased computation, because of today unidentified usage. So the well-known unknown unknowns, things will happen that we cannot predict. And even though I see great strides in efficiency as well, that we touched on, I suspect that overall the efficiency will not compensate the increased usage going forward. Partly because there's a limit to the efficiency. So if you replace a very very power hungry fridge by a brand new efficient fridge, or the same with the light bulbs, uh, then the potential to have the similar impact is nowhere, right? If you go to 100 to 2, then you can go from 2 to 1, but you won't go to minus 90. So you cannot have that much impact. Um, but yeah, I think the future challenges would be great because the investments would be massive as well. There's a really big need to actually dig trenches and then build buildings and create complex technology. Um, the nuclear sector is absolutely fascinating. There's a lot of very promising technology there as well, with reactors that are able to work with spent fuel. So not only would they, release electricity, but they would actually clean up the existing uh, backlog of energy, the existing backlog of fuel as well. So it's a complete win-win. Um, so yeah, there's a lot of things on the horizon that are fascinating, consequential. Yeah, it's a field to be.
Well, Laurent, thanks so much for joining us and giving us a bit of an overview of the way AI is impacting power and energy. It's been fascinating to chat about.
Thank you, Sam. It was fun.